Okay. All right. So 6.1. Okay, let me say something about the quiz. On problem number 2, if you got like a negative number, that actually was an okay answer. Okay, in terms that it should be negative, but obviously, in terms of what we learned, negative doesn't make sense. So what I'm trying to say is that one of the values, I think, was 258, should have been like 248, and that would have given you a positive value. So for problem number 2, what I'm going to do on your quiz is just check your process. If your process is okay, you're fine. Okay, that's what I'm going to do. All right, so just letting you know that. All right, so three-dimensional property of three-dimensional space. You should have done some of these in probably pre-cal or something, correct? So the idea is that now we have three-dimensional space. So we have X, Y, and Z. So everything on the three-dimensional space is going to be represented by 3 points in 2 dimensions. Three coordinates. In 2 dimensionals, we represent X and Y. So we need to add 1. In this case, the Y, which represents kind of the height. Okay. So let's see what we have here. So we have the midpoint between 2 points in the space and the distance formula in the space. And all we do is expand the same concept to 3 dimensions. So how do we find the midpoint? We find the average between the X coordinates, the average between the Y coordinates, and the average between the Z coordinates. Okay, let me see, somebody else is here. All right, so for the distance in 2 dimensions, that's the formula for 2 dimensions. The change on X squared plus the change on Y squared, the square root of that will be the distance formula. For 3 dimensions, then we just add 1 new dimension, which is the distance between the components in C, okay? So go ahead really quick, please, and try to find the midpoint of each of these pairs. So all you gotta do is find the average between the coordinate points, okay? So Alex, let's try that. Baru, everybody.
Do we say them out loud or do we put them in the chat?
You can actually put them in the chat so I can check the chat. And in that way, we'll be faster, okay? Barum, all right, Barum. You're good. Leanne, that's correct. So it should be 2.5 or 5 halves, 3.3, 5. All right, so this should be 5 halves, 3, and 5. What about the second one? Andante, I agree. Andante answer, man, come on. Part 2 should be 0.5 or a half, -5, and 5 halves, right? Easy peasy, just extending that. So what about the distance? Go ahead and put that on the chat, everybody. Find the distance between both of them. So A, right, should be, the distance should be the square root of 69. What about the next one? The square root of, the distance should be the square root of 34. So you got those two, that's all, right? It's just an extension from 2 dimensions to 3 dimensions, okay? Nothing really out of the ordinary there. All right, so when we're dealing in 3-dimensional space, obviously, there are gonna be shapes that actually fit 2 dimensions. A lot of times, we're gonna be using triangles to actually solve some of the problems. So this is just a review of what we've done for trigonometry of a right triangle, correct? So this is sine, which is opposite over adjacent, BC. I'm sorry, opposite over hypotenuse. BC is the opposite and AC is the BC is the opposite, AC is the adjacent. That's incorrect. Do you see that? Because sine is opposite over hypotenuse. So this is incorrect. And cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent, right? So this here is incorrect. At least that one is incorrect because it's the same thing that we have done for trigonometry, all right? So we're gonna try to use that here, all right? So it says that consider a cuboid with edges 5, 6, and 7. Find the length of the diagonal. Yes.
Isn't the sine data and the tangent data switch place like on the top?
Yeah, that's what I'm saying. These two, this is incorrect. Looks like this one is also incorrect. So just remember what we know from trigonometry, or just remember the SOHCAHTOA thing, right? So SOHCAHTOA is opposite over hypotenuse, which is sine. Cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent, okay? Just try to remember that. Obviously here there is an error there. All right, so it says, example 3, consider a cuboid with edges 5, 6, and 7. Find the length of the diagonal of the cuboid. All right, so let's try to illustrate that. So we have this kind of shape, and my scale might not be the best one. So just bear with me because I want to make this the best I can. No, that's really bad. So let me redraw this thing, because otherwise the shape don't have a good shape here, then I won't be able to illustrate what I want. It's a little bit better. So we have this thing. I want to put here the Z axis. Here I want to put the X axis, and I want this to be my Y axis. Okay, so basically I'm putting the origin on this corner. Okay, so I need, according to the problem, I need the diagonal. I need the diagonal, and the diagonal will go from the origin to this point. So what are the coordinates of this particular point? When we work in 3 dimensions, we follow the order in which the point or the coordinates are given. In this case, so if this is the x-axis, then 5 is the first component on the x-axis, 6 is on the y, and 7 is on the z. So this piece here is 5, okay? So we go from the origin to there, that's 5. Then we go 6, that means we're right here at this point. And then we go up 7. So this point, that point has coordinates 5, 6, and 7. And then the diagonal of this cuboid will go from the origin to that point. Okay? So if we need to know the length of that, all I need is the distance between this point and that. And this point is the origin, 0, 0, 0. Okay? So all I need is the distance formula. And the distance formula is the difference between these points and 0 squared. So at the end, it's just the square root of 5 squared plus 6x squared plus 7 squared. Okay? And then that distance is the length. So this is part A, right? So that distance is going to be 25 plus 36 plus 49, 110. So that's the length of that. Is that clear, or is there any particular question? We good? All right. So part B says find the angle that the diagonal makes, sorry, with the 5 and 6 face, right? So, well, there are two faces that are 5 and 6. One of them is in the bottom, correct? 5 on the X, 6 on the Y, and there is one at the top. 5, because this one is also 5, and that's 6, right? But we need to find the angle that the diagonal makes with the 5 and 6 face. So I'm going to actually use the top because it's easier to illustrate, okay? But it should be the same if I use the bottom face. All right, so look, to find the angle between this diagonal and the top face, so basically what I'm going to do is draw a triangle. I'm going to draw a triangle from this point, actually from the origin to this vertex, okay? And then from that vertex to the 0.567. So it's going to be something like this. So that red triangle should look like this. What type of triangle is that, by the way?
Right triangle.
I'm sorry, say that again, Lian.
A right triangle?
It is a right triangle. Where is the right angle, Lian?
It's the place where it has like the Z sign.
Correct. This is where we have the right angle. This here, so basically this side, everybody, this side is this one, okay? This hypotenuse is the diagonal, okay? And then this side is this one here. Does it make sense? So on that triangle, if it goes from 0 to this vertex, so that's the height, that's 7, right? The diagonal, which is this, is what we just found on the previous step. So the diagonal has a length of 110. And the angle we're looking for is this angle, because it's the angle between the diagonal, I'm sorry, and the face, right? So this is the angle we're looking for. Does it make sense? So this is data. So in a right triangle in which we know the opposite and the hypotenuse, so how can we find data?
Sine.
Sine. Sine of data is opposite over the hypotenuse. And then we use the inverse sine or the arc sine function to find it. So data should be equal to the sine inverse or arc sine of 7 over the square root of 110. And that should give us whatever the angle is. I don't know how much that is. 41.87. All right. So then data is about that, 41.87. Okay. That means that you should be working in degrees. Otherwise, radians will be very small number. Okay. Just make sure that your calculus is in there. All right. So that's part 3. All right. So I want to see how you will tackle this problem. What would you have to do? So it says ABCDE is a square-based pyramid as shown in the diagram below. Find the angle that the edge AB makes with the base. So we have this edge AB, and we want to find the angle that this edge makes with the whole base. So what should we do? Any idea?
With the triangle, I think.
We
On the
need a
diagonal,
triangle.
the base square.
Yeah.
So we need a triangle. The base of that triangle goes from where to where?
BD.
From B to D, correct. So we need this, right? This is the edge. So we're looking for this angle.
Is the answer 59?
Did I do that? 59.
I have a different answer.
No, I don't have that. Okay. All right. So let's look at this, right? We have this angle. So how do we find that? Let's redraw in 2D the situation that we have. We have AB, and then we have this here. But really, in reality, we have this triangle, right?
You have to divide the diagonal by 2.
Right. This is 10. And we need this diagonal divided by 2. Well, this diagonal is the diagonal of a what? Right triangle, right? Because this is, I'm going to redraw this here. 6 and 6, 6 and 6. This is the right triangle because they tell me it's a square base. So this diagonal is this one. Do you see that? And this diagonal by the Pythagorean theorem will be a square root of what? 72, right? Because it's 6 squared plus 6 squared, a square root of that. This is a square root of 72. So that's the whole thing from here to here. We only need what? Half of that. So to find the angle that we want, which is this, in this case, what do we have? We have the adjacent and we have the hypotenuse, right? So cosine of that angle is going to be the adjacent 1/2 a square root of 72 over the hypotenuse, which is 10. So theta will be then the cosine inverse of the arcsine of 1/2 a square root of 72 over 10. Tell me what you got.
I have 64.89.
That's it. 64.91 or 81?
89.
Now, you don't want to approximate this, okay? So make sure that when you're using your calculator, what I'm saying is don't round this. Don't use a decimal here because you're gonna round here and you're gonna round there. So you're gonna lose accuracy, okay? On these type of problems, always try to round one time at the end or approximate at the end. Otherwise, we might make mistakes in the middle, okay? Sorry. All right. So any particular question for number 3 or 4? Are we good? Okay, awesome. So let's look at the next problem here. Find the volume and surface area of these two shapes. For the pyramid, if you have your booklet handy, I want you to see if you have those formulas available to you. I don't think you do have the surface area of a pyramid.
I don't think you don't.
But you may have the surface area of the sphere. Okay. So let's look at problem 5, right? Find the volume of the surface area of these two shapes. So obviously, this is a rectangular pyramid. The edges are 7, 5, and 8. So we need the height, right? We need the height. How do we go about to find the height? Same process that we just did in the previous example. Meaning, we want to find half of the diagonal size. The diagonal is the hypotenuse of a right triangle with lengths 5 7 and 5, right? So this diagonal is the hypotenuse of this triangle. So go ahead and find that. That will be 25 plus 49, 74, right? So this should be the square root of 74. Yes? But we need only half of it, right? So this is for the base in order for us to find the diagonal of the base. But the height, then for the height, we have this situation. Half of the square root of 74 is the base. So now I'm talking about this other triangle. The edge is 8, and we need the height. This is the height of the pyramid, okay? So after you do the, apply the Pythagorean theorem, so on and so forth, the height of the pyramid, you should get this. You should get the square root of 91 halves. That's by using the Pythagorean theorem. This is by using h squared is equal to 8 squared minus 1/2 square root of 74, everything is squared, and then solve for h. Okay, that's by the Pythagorean theorem. You should get to that. All right. So why do we need the height? Because we need the height to find the volume, right? So what is the volume for my pyramid? What's the formula for the volume of a pyramid?
1/3 multiplied by the base multiplied by the height.
All right, so 1/3 length times width times height, right? And now we have everything. This is 1/3. We have the length 7, the width is 5, and the height is that number. Okay, so then the volume, I'm gonna do the volume here. So the volume is gonna be 1/3 times 7 times 5 times that number, square root of 91/2. And I got about 78.69, so about 678.7. Okay. Try to verify if I didn't mess up. That's just the volume, right? That's just the volume of that. How do we go about to find the surface area?
It's the areas of all the faces.
Is the area of all the faces, right? In your formula booklet, you don't have a formula for that. All right, I'm gonna give you a formula for it. So it's up to you, you memorize it, but I just wanted to give you the formula. All right, so for the area of the pyramid, as Leanne said, is the area of all the faces. So how many faces do we have? How many?
5.
5. Let me see the base.
Oh no, wait, no, I missed.
triangle,
Wait,
one
1,
square.
2, 3, 4. Yeah, 5 faces.
5 faces. Some of them repeat, right? Some of them have the same area. That's what I mean, correct? All right, so 1 is the length times width. That's for the base, correct? That's a simple one. Plus, and then we need to add the length, which will be, let's say, the face where I have the 7. And I have to multiply that by the height, because it's a triangle, right? And it's twice of those, correct? So it's gonna be the square root of W divided by 2. Let's say this is L, W, and that's H. So W divided by 2, divided by 2 squared plus H squared. There are 2 of those, correct? And it says, so each one is a triangle, 1/2 the base times the height. That's what I'm doing. Since there are 2 of those, that's why there is no 1/2 anymore. Do you understand that? So the other, there are two of those also. So it's going to be then the width times the square root of the length divided by 2 squared plus h squared. That actually is a formula that will give you the surface area. Does it make sense? This repeat twice, that repeat twice, and since the formula has a half, then they cancel each other, the 1/2 and the 2, and that's why you have that. Make sense? All right, cool. So having this formula, then go ahead and, well, no, it's too complicated. Well, it's not complicated, it's just time consuming. So you can do this on your own, okay? Now let's do part B. So this is, all this was A, okay? Let's try to do part B. So we have the volume of the circumference. What's the volume of the circumference formula? You do have that on your booklet, but does anybody
It's
remember?
4/3 pi r cubed, I
4
think.
third pi.
Yeah.
R3 pi r cubed,
R cubed.
right? So in this case, they're giving you the diameter, 18.3, right? So we need to divide that by 2 and cube it. So the volume here is going to be 4/3 pi 18.3 divided by 2 cubed. And that will be just the volume, right?
It's like 3,000 something.
3,208
There you
point
go. That.
something.
I'm going to believe you. Okay. I trust you. What about the surface area? What's the formula for the surface area of a circumference?
4 pi r squared. Wait.
Yes, that's correct. 4 pi r squared. Okay. So this is then 4 pi times 18.3, halves of that squared. And that should give you the area, the surface area of the circumference. Make sense? Any question? I want you to make sure that you do finish this and that you see that actually that formula works, okay? All right, so let's move forward. We have 2 more minutes, at least let's think about this. At least let's develop a strategy. It says a pipe of thickness 6 millimeters and an outer radius of 2 meters, and I'm sorry, and an outer radius of 7 centimeters is 2 meters long. Find the volume of the material required to make the pipe. What do you have to do? What's the strategy there?
Convert the units.
Okay, convert the units because you need to change the 6 millimeters into meters, right?
Or centimeters.
Or centimeters. Or centimeters, right? You can change everything to centimeters if you like to. Now, once you have that, what would be the next step to take?
You take the larger cylinder and you subtract a smaller cylinder from it, and then you get the space that's between.
Right. That's all you gotta do. Find the volume of the big cylinder, subtract the volume of the small one. What is the volume formula for the cylinder?
Pi r squared h.
Pi r squared h, right? The base is a circumference, so that's why the area is pi r squared, and the height in this case is gonna be the what? The 2 meters, right? So the problem, you can say B1 minus B2, where B2 is the inner volume and B1 is the outer volume. Okay, that's basically the strategy. So just use that formula, make the conversion, and you will be good to go. Okay, man, first time I finish at 12:30.
Mr. Sanchez, can you give
Yes,
the
sir.
answer for 5B?
5B. I don't know. Let me do it.
I mean 5A, the area.
The area formula. You know what? I actually didn't do it. I just put the formula there. Okay, the formula.
I have 110.69.
110.69.
Yes.
Did anybody do it? Can anybody confirm that?
Yes, sir. I also got 110.6.
Yes, you got that? Awesome. So that's it, Adam. Okay. Hey, by the way, I did graded the quizzes, not the last quiz, the other one. I need to put those in Canvas, okay? But I have those graded. I'll be putting those updating the
When is
grades
the quiz correction?
soon.
Oh no.
Yeah, I guess I'm gonna have to scan all that and email it to you or something, because that's the only way I can think of to give you the opportunity to make corrections. Okay. So, but so it's coming soon in a HL class near you. All right.
How well did we do?
So hey, in some parts, man, I don't know. You need to be better organized, some of you, because it's so difficult sometimes to actually read what you try. And look, you need to avoid, this is not a coding class, okay? It's not coding. You cannot put arrows from one end to the other end like it's a puzzle. You need to get organized, everybody, you know who I'm talking to in this case, all right? Because it's like this. There is an arrow to there, and then it's like here. There is another arrow towards there, and then it goes and does this spiral like that and goes there. And like, what the heck is this? It's crazy, okay? I'll try my best. All right?
Yeah. Mr. Sanchez, I saw the lesson preview for this topic. We basically use differentiation to find volume and all that, and we use differentiation with trigonometry, right? In this topic.
In this topic?
Yeah. We use differentiation with trigonometric functions.
We might, but right now in chapter 6, I think what we are, let me see. We're just doing three-dimensional space. I don't think that we actually go that length. Let me just double check. Because we go properties, angles, ratios, trigonometric functions, trigonometric equations. Manas, I don't think we go that to that length of using, we might use differentiation, but I don't see it in the topics. Okay,
Is this the
or
last
a review of a lot of the trigonometry that you guys did, but without the extension in the 3D space, okay?
Is this the last topic of the year? Or?
Probably so, yes. I don't think, our goal with Ms. Spears is to be able to finish chapter 6. And if we finish chapter 6, we will be good for next year, okay? So any other question?
I heard that we'll have 2 tests before the end of the school year. Is that true?
I don't know. Ms. Spears and I, we didn't have that conversation yet. So unless she mentioned that to her other classes, but we haven't had that conversation. Okay. Any other question?